How to measure CPU usage in Linux? What is CPU load average and how it is different from CPU utilization? CPU utilization shows the percentage of samples that have found the CPU was busy over the measured interval. But measuring the utilization in percents is not quite accurate. If top reports that your program is taking 23% CPU, then 23% of the samples taken by top found your process active on the CPU. The rest of the time your application was in wait. Remember that the CPU is a discrete state machine. It really can be at only 100% utilized executing an instruction, or 0% utilized waiting for something to do. There is no such thing as using 23% of a CPU. And the CPU percentage is a function of time. Load average shows how many processes are waiting for their running slot. In other words, it shows how many processes are ready to run, but they cannot because the CPU has no time for them just now. It is measured and displayed as an average value for the last 1, 5 and 15 minutes intervals. Let's imagine we have a 4-processor machine. It can be visualized as a 4-lane freeway. Each lane provides a path on which the processes can run. A vehicle can represent those processes. There are vehicles on the freeway, and there are vehicles waiting at the entrance lanes. If all freeway lanes are jumped, the cars entering have to wait for an opening. The CPU utilization percentage represents the relative amount of time each vehicle was found occupying a freeway lane. Process 1 was found active at each check during the sampling interval. And process 2 was found active at 66% of the checks during the sampling interval. That gives a picture of how each process is utilizing the CPU, but it does not show the demand for the CPU. And here comes load average. Load average includes the cars on the freeway and also the cars that are queuing up and are waiting to get on the freeway. In a non-rush hour there could be little demand for the freeway, but there just happens to be a lot of cars on the road. The CPU percentage shows us how much time the cars are using the freeway, but the load average shows us the whole picture, including cars that are ready to use the freeway but are waiting for a slot. In a perfect world, the perfect utilization will mean that the CPUs are always busy, and yet no process ever waits for one. If there are 4 CPUs on a machine and the reported 1 minute load average is 4, then the machine has been utilizing its processors perfectly for the last 1 minute. This is the same for the 5 and 15 minute averages as shown by the uptime command. But how is load average measured? In the Linux kernel, each dispatchable process is given a fixed amount of time on the CPU per dispatch. By default, this amount is 10 milliseconds. For that time span, the process takes over the CPU and executes its instructions. In the common use case, the process will give up control to the kernel before the 10 milliseconds are over. It could be through socket calls, I/O calls, or calls back to the kernel. Actually, 10 milliseconds is quite enough time. For an average CPU, this time will be enough for executing 2000 million instructions. If the process uses its fully allocated CPU time of 10 milliseconds, an interrupt is raised by the hardware, and the kernel regains control from the process. That time slicing is an important design concept for making the system seem to run smoothly on the outside. These 10 millisecond slices are also used to produce the load average values. One more thing. When a process is ready to start, it is placed in the ready to run queue. Then it is picked by the scheduler and dispatched to the CPU for execution. A process can be blocked, waiting for an I/O operation to complete. In this case, until there is demand, the operating system will schedule other processes to run. However, the process waiting for I/O will not progress till the issued I/O operation is complete. The percentage of time that the CPU is idle waiting for the I/O to complete is called I/O wait. High I/O wait can at times indicate a bottleneck in the network or disk subsystem of the machine, and is a sign that further investigation is needed. Back to load average. There is no problem if load average is less than the total number of CPU cores. But if it gets higher than the number of CPUs, this means some process will stay in the queue, ready to run but waiting for free CPU. Values much higher than the number of CPU cores indicate system congestion and bottleneck. To wrap this up, CPU utilization in percentage shows the amount of time that the system's processes were found to be active on the CPU for the measured interval. CPU wait average shows how many processes are waiting for their turn to run. Wait average do not include any processes or threads waiting for I/O, disk, networking, or anything else not demanding CPU. It focuses precisely and only on the required CPU time. And that's it. Thanks for watching.